Hello and welcome to Hadoop Exam Learning Resources. This is a supplementary sessions of Module 2. In Module 2, we have discussed regarding the how file read and write operations happens. This was just an overview of over that. Now we will go in depth with in this session how file read and write happens in the HDFS. So for this we will discuss distributed file system object as well as FS data input stream and FS data output stream, and also we will see what happens while reading the file if some error happens, or while writing the file some error happens. So how HDFS handles this all failure conditions. So let's move to the actual our sessions. Okay, let me clean out the screen first. Okay, so now let me compare the conventional file system first with the HDFS file system. HDFS, correct? So now in the conventional file system you can create a file, you can delete the file, you can write to the file, read file, create directories. I'm just writing to give you the comparison, and delete directory. Similarly, this all the operations are supported in the HDFS, correct? However, it's like updating the file is possible in this conventional file system, but in this you can only append to the existing file, you cannot update the file in the HDFS file system. Okay, but however other than that you can create the file, you can delete the file, you write to the file in append only, you completely read the file from the HDFS. Obviously you can create directories to maintain like proper what do you say, managing the file system files in whatever folder structure you wanted. Delete directories and update, as we have discussed, update is not directly supported in already written files. It's like somehow you have to create a new file and then you have to replace your existing file or something to get the update. Or other than this, if I would say block locations, correct? In conventional file system, if you know, there's also like this file is actually returned to the file system. In the conventional file system also it creates a block, but this block size is very small, 64 KB, correct? The one's block size. Similarly in HDFS, this whole file is broken into the like block size, but the block size would be either 64 MB or 128 MB in size based on the configuration. So this is also written to the, these blocks are written to the your data node. The only difference here, you don't read the block locations because you don't need it, correct? Here some framework requires to read your block locations, read block locations. Why? We'll discuss. This block locations reading is required in the HDFS file system. Why we need to read the block locations? This allows MapReduce framework. So suppose you are running the MapReduce on this framework. So let's assume this is MapReduce flow is running on each node. So each node can locally read your block locations. This block locations can locally be read by this MapReduce framework, correct? So you can run the parallel processing on each individual block. So that is what the reading of block location is required in case of HDFS file system, because we are running thousands of mappers and reducers in parallel over the MapReduce large cluster of our Hadoop framework. So that's why we need the reading of the block in parallel in the HDFS file system. So now let's go in detail how file reading happens in the HDFS file system. So let's assume, let me draw the diagram over here. Okay, so this is end user, as in you want to read the file so you cannot directly read the file from the HDFS. Okay, so there is your JVM. Okay, this is client JVM. We are assuming this is or I would say Java platform you are using. So as an HDFS client library you would have to use, that is HDFS client library you have to use to read the file. Okay, so what happens we will see in detail. Okay, so now as a first step, from the HDFS client wants to read a file, it has to call an open method on the distributed file system object. So this will help you to do the like interacting with the HDFS file system, this distributed file system. So as an end user you will call the open method on this distributed file system. So let me draw the diagram for next step. Okay, so this is your distributed file system in your HDFS client. It is going to call an open method on this. Okay, so what exactly this open method looks like? It's like you will call open method with the path as an object as an input and file system would be written, and similarly over the output would be FSDataInputStream. I'm just giving you the example over here, not complete Java code. Okay, so this object would be returned to you, and here as an input would be what? File name which you want to read it. File name you want to read it, so you call it. Now as a second step, what happens is exactly distributed file system's responsibility to get all the block locations of your file. So you know your file is divided into, which is you want to read it is divided into the multiple blocks. So let me just draw again. This is your name node, correct, in the Hadoop clusters, and there are 3 data node 1, 2 and data node 3. These 3 locations data nodes are holding your all the blocks, which makes your complete file. Okay, so each node has 2 blocks, okay, holding it. Okay, so now you want to read this file. So what happened for distributed file system will call, as soon as you call open method, it will make an RPC call to name node to get the block locations. This is second step, to get the block locations. Give me all the block locations in the for this particular file. So how API would look like? So distributed file system will call get file block locations, this is file path, which is similarly you have inputted over here, and it will return you the block locations over the your whole Hadoop cluster. So what exactly is this block locations contains? This is the just collections of host name, and what happens if file does not address? Simply it returns the null value. It would have null value stored in, so that the file does not exist in the file system. Okay, and also keep in mind the block locations which are written in sorted order. What does mean here in sorted order of hosting? The sorting is based on the proximity or nearness of your block with the client. So suppose you are reading a file from the Hadoop cluster which has cluster expanding to various regions, one Asia Pacific or one US region. Okay, let's assume this is your one data node in New York. and another data node is in Mumbai in India. Okay, and this client which is calling to read the file stays in New York. Okay, this is in New York. So which copy of the block should be written? Obviously which is near to this New York block locations would be written as a part of the return array of that name node. So this will return the block exists in this. So this is sorted list. Also this it is also get the this Mumbai location as well, but it is just for information where this until and unless this reading of from this data center goes failed. If it is filled, then this we see the situation where what happens with the failure condition. So that's why it would be always in sorted order. And it is also possible data node itself could be client. Okay, so it might be possible like you are calling from like this node itself, you are reading the file. So what happens, this file will return local locations of the block, and this file, this user or library can directly read the file locally from this file. So it is the scenario where if you are locally calling this block. Okay, so now let's move to the next step. How the block locations are not directly returned to the client is the third step. Block locations are not directly returned to the client. What client gets it? FS data input stream object to read the file, correct? So this part won't be there in the Java if you have worked in Java. So data input stream object would be written, which happens again internally, which manages this object manages input output with your name node as well as with data node, correct? This data node, because this has now this is storing your whole sorted block location. So let me go in diagram. So this FS, another object, data input stream, which holds your complete block locations in sorted order to read the file, correct? So now this is the third step where it holds your, what do you say? Okay, so this holds this as a part of second step, but as an end user now you will call the read method on this object, and which based on this block locations it would say could be DN1 or DN2 or something, DN3. It's kind of sorted. So based on DN1 it calls the read method continuously on this, and this will happen continuously until it reaches the end of the block and transparent to the client end user. So client will call the read method on FSDataInputStream, which has stored the data node addresses as we have discussed for the first few, only first few blocks. Okay, not all the blocks of the whole file, correct? Then connects to the first closest data node. So this is, we are assuming this is the closest data node for the getting the first block of the file. What is the next? Data stream from data node block to the client, which calls the read method continuously. This is so like continuous stream. So it's like the data would be written from here to the directly the client as a fourth step. Okay. Now what happens when you reaches the end of the block? So as soon as you reaches the end of the block, input stream close the connections. Okay, so we have fourth as a read continuous stream, continuous stream, continuous stream. Okay, let's move to the fifth step. Reach end of the block So what happens, input stream will close the connections with that particular block, close the connection with that particular block and open a connections with the new block, whatever in the proximity available, and this happens completely transparent to the end user. So for end user, you are still reading continuous file, you are not aware like this switching is happening from this node to this node, but and as an end user you don't have to know, even because you are interested in the complete file rather than just on a reading a particular block, correct? So for once you have started reading a file, it has to give you the complete file. It will also call the name node, okay, in between. If something as a this FS data input stream will call, like if doesn't have the block location for further to read, it will make a call again to the data nodes to give me the remaining or further block location, so I can start reading from there. So that happens as a part of the step, okay. And at the last, when you are done with the reading all the blocks in this, you are done with the all the blocks, all blocks has been read, then close method would be called on FSDataInputStream to close the your file connections which you have opened it. So as a sixth step on this, you will call a close method on this, and on this FSDataInput. So this is the whole part where this is relatively lesser complex than writing a file, but this happens during the reading the file. So error handling while file read, okay. So now what happens when you are reading a file and something goes wrong? So let's say, assume during reading DFS input stream encounters an error. So okay, while you are reading the file and there is an error happens, okay, I suppose there is an error during that reading of the file, because there is a communication error and some network goes down with this data node, and then it will try next closest one of the block. So what happens, like it has the list unsorted order with it, correct? So if this connection goes down and something, then it directly calls the next block available on the data node in this, okay. So okay, just a minute. Okay, so now if it will also remember data nodes that have failed. So what happens if this node goes down or some communication breaks up, it will start reading the file from the next nearest locations of the data node, and it also remember the nodes which has failed during the reads it found and the address of this node for other blocks. So it won't start reading from this block because the error happens on this, and same could happen again for the another block while reading, suppose. So it whenever the next block has to be read, and in his address list if this block exists over here, then it's blindly ignore it and read it from the another data node. So while reading, and after one block reading is completed, let's assume it you are reading a file and one complete block is read it, but after reading the block you found the block is read by like this FS data input stream file, like whatever it has read is like this block is corrupted, something like you can see like this is the line and some 0 something happens and it says corrupted file. How it identifies whether this block is corrupted or not? Because it is not reading the content, correct? It's reading the content but it doesn't understand what is in the file. So how would FS data input stream get to know whether the block whatever I have read it is wrong or something corruptions after reaching to the client, end user looks into this and then it's again read it? No, this is not possible. This guys has to identify what happens if this whatever I have read it is correct or something wrong with that, then what exactly it does actually. There is a when the okay, let me go over here. When there is a block stored in the data node, in the block stored, so it is stored on not only two things is stored actually. One is your actual data content in the block, and second is some metadata related to this block. What this metadata contains? Many information. One of this is checksum. Checksum is the best way to identify the data which you have read. It's same as the which has been written to the block. So if after reading the complete block, it compares the checksum of in this file and as well as checksum of the new block would be compared. So checksum FSDataInputStream object will compare the checksum of the block which is already stored in the this metadata and the new block which is read. And if it found there is a difference between checksum, then it considered this block is a corrupted block, and if there is same checksum, then it is okay for it to be go ahead. So this way it handles like to identify whether whatever it has read it correct or not. Each block replica on a data node, okay, so same thing represented by two files. One is the main data file and another is the your checksum as well as generation step when it was generated kind of thing also stored over here. Okay, if it finds the checksum is not patching and block is corrupted, then block will be considered as a corrupting. Okay, now if a corrupted block is found, it is reported to the name node. At the same time, it's like before reading the name next block locations, it also report it to the name node as well that this node data node is corrected. So hence overall client contacts data node directly to the, okay, so this is the conclusion what happens while reading the file. So while reading the file, client directly contacts to the data node. So reading happens through the data node, not through the name node. So this is a very important question from the certification perspective. So from where the data directly read by the client, so it's directly read from the data node, and name node just guide the best data node for the reading. So it is just guide where to read, what which is the nearest location or something, which allows HDFS to scale large number of concurrent clients. So you can have lights, another clients reading the same file, another clients reading the same file concurrently. You can completely read the file because each data node has independent traffic to the another data node, and name node is just do a guide operations for this. And since the data traffic is spread across the data nodes in the cluster, the name node meanwhile merely has to service the block locations only, correct, as we have seen, which is in memory. Okay, so okay, all the block location is also stored in memory. Okay, so this information is always available immediately, so this operation will be very fast while reading from the name node, correct. So this operation helps to read it in very fast. Okay, let me pause here. Now let's discuss how file write happens in the HDFS file system. Okay, so let me draw again the same diagram. So this is your end user who wants to write that big file into the file system. So this is your HDFS client. Okay, this would remain in the your client JVM. which is going to write the file. Okay, similarly here also we would have distributed file system object, and there is a FS. Okay, I would later on I'll come to that topic. Okay, so let's first, if the client create a file by calling the, as a first step, client will call create method with the file path in the on the distributed file system object. I'm not going to discuss it again. Distributed file system object. Okay, you directly call it, and distributed file system makes an RPC call to the name node. Now this is again same thing. This makes an RPC call. This is second step. This is your create method, you will call it as a first step, where in reading it could be open. Correct? So this is RPC call to name node and create a new file in the file system namespace. So it will ask for the creating the namespace file system. So what exactly the name node does is, name node has to do the some checking before giving the right permission or something. So the name node performs various checks to make sure the file does not already exist. Okay, first check file should not already exist before, because you could overwrite this file or something could wrong goes happen, or file could be corrupted. The client, whether the client has this right permission or not to write the file, correct? That also, this is normal file system checks also, and this check pass or fail, correct? If that check fail, what happens? It will throw input output exception. That's all. Okay. Or if this check pass, then it will makes a record of new file. New file record has to be created in the name node. Okay. And so similarly, this create call goes to up to this name node, and then it will identify this thing. The distributed file system returns FSDataOutputStream. Now here what exactly the new object will be written? The FSDataOutputStream. That in case of read it was input stream, in case of write it is output stream would be written by the name node. Okay, and what this helps, this is helping us to the communicating with the data node over the cluster. So similarly, 3 data node over here, little complexity, okay, while writing the file to the HDFS file system. So now this happens, this holds how communication happens. Now clients start writing data through DFS output stream. As a third step, you will start writing, and this write goes to the DFS data actually breaks into. So while you want to write a file, correct, so one block has to be written a kind of thing, so it will divide into your whole file in a small package. So while writing, suppose you are writing into the first data node, it will make a package of data which is being written. So small packets will be created. Okay, so I'll make it longer. Okay, so this packets will be created while writing, and this packet size is 64 KB or something before writing into the database, which is, and it makes a queue. Okay, this is internal queue which is made by a DFS input stream, and that is called data queue, which has to be written. This is called data queue. So what exactly is after that? Data streamer, which is responsible for acknowledging the, asking the name node to allocate the blocks by picking a list of suitable data nodes to store the replica. So there is a data streamer in between comes. which asks give me the proper block locations where I can write this packet. Okay, so this is in part of your third step would be right asking the block location where to this packet has to be written. So now data node pipeline would be created. So before writing into the database based on the block locations written by this name node, correct, based on block locations, like it says name node will says you store your file blocks in 3 data nodes, that is data node 1, data node 2, data node 3. So what data streamer does, it will create a pipeline. I would say this pipeline of 3 node, because this has to be written in this pipeline. New pipeline would be created for this has to be written. The list of data node forms a pipeline. 3 node pipeline for a block will be created because replication factor is 3. Okay, so why 3 node block pipeline? Because we wanted to create a block in the 3 node while writing into the file system, because our default replication factor is 3. The data streamer streams the packets to the first data node. So now data streamers pick up these packets and push into the first data node into the block. So this your internally first packets will be written. Similarly, these packets once written into the data node 1, it would also ask to store by the data node 2 similarly, and at the same time it will also ask you also write the block. So same packet has to be written into the 3 block locations in 3 separate data nodes in the pipeline, which stores the packets and forward it to the next data. So this forwarding happens while you are writing into the this data node. Okay, so this is the way the use of the pipeline, okay, while writing the data node. And this pipeline is created based on the topology of the network, which like makes sure like the data has to be replicated in the same rack or in another rack or something. This has to be managed by the name node, and based on that information the name node will return you the block location where you wanted to store it. So packets are forwarded into the third data node of the pipeline. Now data output stream also maintains an internal queue of the packets that are waiting to be acknowledged by the data nodes called the acknowledgement queue. So there is another queue which data stream maintains. Okay, let's assume this is another packet stored and this. So whenever there is packet has to be written, one packet is added into the this acknowledgement queue. This is acknowledgement queue. As soon as data streamer get information like all the 3 nodes has copied the packets, so now it removes these packets from the acknowledgement queue, because writing has been finished for that particular packets. A packet is removed from the acknowledgement queue only when it has been acknowledged by all data nodes in the pipeline. Okay, all the pipeline has removed. Now next step, which client has finished writing the data, when client has finished with the writing the data, then it will make a close connections on this. This is the sixth step. On the stream, this is FSDataOutputStream. This action flushes all remaining packets to the data node pipelines and wait for the acknowledgement. So it would wait for the acknowledgement, whatever has to be written. So close connection would make and all this, and the once acknowledgement queue is all the packets has been written would be empty, and this would also be empty. And once acknowledgement is received, then signal that file writing is complete. The name node already knows which blocks the file is made of. So this information in name node's memory, like all the block locations will be stored, which blocks of the file is made of via data streamer. So it has to wait for blocks to be minimally replicated before returning successfully. So minimally replicated, it means like whatever, like at least minimum replication. We will see what is mean by the minimal replication. So now the questions arises over here, let me clean out this again. Why data node forms a pipeline? Why data node pipeline is created? Have you think of this? What is the benefit of having the pipeline? Because it reduces the network traffic, because you have created three data nodes and you have predefined pipeline where data has to be written. So it has predefined, so it not look for the which data node next I have to replicate. So it's pre-created the pipeline, and then which reduces the network traffic, and this pipeline is created based on the client locations. Okay, so like it would try to get a list of data nodes which are very distance also considered among the data node by to reduce the overall network traffic. That is why the pipeline is created. The second question is what is the packet? We have discussed packet, correct? So we have little bit also discussed on this. This packet is just a buffer size, 64 KB buffer size, which has to be transferred over the network in the form of packets, and then this packet is written to the your data node. The next packet is pushed to the pipeline before receiving acknowledgement of the previous packet. So in queue it would be added and it would be written before getting the acknowledgement, because it could happen in parallel, as you can see here. Like you could keep pushing it, it won't wait for the all the packets to be completed and then remove from the acknowledgement and then send the next packet. No, it won't happen. So as soon as it send the information like one packet has been written, similarly it keeps sending the writing the packets, and as soon as this information data stream receives like any packets has been written, it could be like first this packet is written and then this packet is written or something, this information. So then it keep removing this packets from the acknowledgement queue, but it's finally the file writing is in sequential, the order in which you want the data. So the block could be replicated in multiple places or something, and packets in could be unordered, but the file which is completely written would always be in the same sequence which you are, because you don't want your data to be jumbled in the file, correct? So it would be always sequential only. So now that is what we mean by the packets. Okay, and what happens if you are writing a file and somebody start reading the file in between, like somebody is writing and you start reading that file. So HDFS does not provide any guarantee that data are visible to a new reader until the file completely written. Okay, so the data is accessible only when complete file has been written by the pipeline. Then only this file will be available to read by the end user. Now this is all about file writing. Now what happens if any error occurs? Okay, error during file write. What kind of error could happen? Okay, if data node fails while data is being written to it. Now if you are writing this file and this packet is unable to write, or some because of network connection loss or something goes wrong, or no space is available, anything could happen while writing the file to the data node written to it. The actions which are taken again transparent to the client. When this happens, then these actions, like what your actions would be taken, these are transparent to client. First, the pipeline would be the closed. If one fails, then what happens? First, pipeline will be closed. Would be closed, correct? So whatever pipeline we have created, that would be closed. Any packets in the acknowledgement queue are added in front of, again like this packet which was in acknowledgement queue again moved back to the in front of this queue. Okay, because this might, why data queue, so that data nodes that are downstream from failed node will not miss up any packet. So it's might like you won't lose this packets, you don't want to lose this packet which is already being written and somehow it is being lost by this. The current block on the good data node is given a new identity. Now that this block, suppose this node has failed, So this block would given like previously the name of this block was A and A, correct? These three blocks has some naming. It's like I'm just giving the random name to as an example. Now this node has gone down in this block. So what exactly happens is the new name has been given on this two block, which are two good data nodes, correct? So let's say name node data node block is name is given as a P, and this has to be removed. And what happens, and this identity is communicated like A block has been failed and not completely written into the data node DN1. So this information is stored by the name node, which is communicated to the name node. Because why this information is communicated to the name node? Because this data node could be failed or something or half written, and it comes back into the cluster without cleaning up or something, correct? So this comes again to the cluster. So now name node should be aware that block A, which is available on this data node, is not good. It has to be cleaned out from this data node. So it removes the block which is corrupted. So that's why this new identity is created for new blocks, existing blocks, and old identity would be cleaned as soon as the partial written block will be deleted if the failed data node recovers later on, correct? So that's what happened. And after that, and this failed node would be removed from this pipeline. This failed node would be removed from this pipeline, and remaining blocks data is written to the two good data nodes. So now whatever remaining block for writing this file would be written to the two blocks. Okay, only two blocks, keep in mind, not right now on the three as it is. New node is not added in the existing pipeline immediately. Okay, so like only two data nodes would be written. And once complete block is written, name node notices that the block is under replicated. Now complete block is written and two data nodes pipeline. So now it's name node responsibility. If any node goes down in between and block is under replicated, means it says the replication factor is 3 is decided by default, but it sees like only block is written into the two data node. Then now this name node responsibility to arrange for a further replica to be created on another node. So it would pick up another node into the cluster DN4 or something. If there is an available node, then it would create the under replicated block or another copy of the block on this node, and this happens again in the background, and client has nothing to do with that block, and it arranges for further replica to be created on another node as we have discussed. Subsequent blocks are then treated as normal. Now next block writing is treated as a normal flow. Again the new pipeline would be created with the other node kind of thing, combination of those. So that is the way we handle the file writing, and error happens while writing the file into the HDFS file system. So that's all about this lecture. So thanks for listening, and we hope you are following the HadoopExam.com. So we suggest you to follow us on this, so you will get on the website we have. Okay, let me open the website again, so I'll show you the. Okay, so there's some network issue right now. Okay, so in the website, if you go on HadoopExam.com, I don't have network connection available, so unable to show you. In the right hand side, there is a contact us tab, contact us button, where we have given Twitter link, Facebook link, as well as LinkedIn ID to be in network. So this is the easier way. We are also going to put the Google Plus link. So this is the best way to follow us and to get update. And don't miss to subscribe on YouTube. Whatever new video we launch, it would be you will get an automated email whenever we create a new video. So this is the best way to be in contact, because sending an email continuously to each user could be a problem for us, because it could be considered as a spam, because a lot of email we have to send in, because our learner network is becoming big and big every day. So we suggest you to keep following on this, so somewhere you will get the update whatever we are doing it. And if you are looking for job in the big data world, so please send your resume to resume@hadoopexam.com. We are continuously in contact with the organization which are working on the big data, and they are looking for the good resources on the Hadoop. So please get the help of these things. Actually, we will help you to get the good job and start working on the big data. This is going to be a great and interesting job for next few years, actually, at least, and very challenging. Thanks for listening, and we hope you are following us on www.hadoopexam.com. Thank you.